So with scatter plots, we can kind of make one big generalization about the information presented to us by identifying what the association of that data is. There's three types of association: positive association, negative association, and no association. And we can kind of think of association kind of like slope. The reason why we can't just call it slope is, of course, because we don't have perfectly straight lines. You can only find the slope of a line when it's linear, and these graphs are not linear graphs. But like we saw in the warm-up, we can see that it kind of forms a straight line, right? A general direction that these points are going, and that's what association is. So if we look at this first scatter plot, we have a positive association. We can tell that it's a positive association because from left to right, we're going uphill. With positively associated scatter plots, as the independent variable increases, which is my x, as the independent variable x, remember if you've got an x, you're independent, right? I don't need my x, I'm independent. So independent is x. As my x increases, my dependent variable y also increases. If you remember from yesterday, our dependent variable is y. If you're dependent on someone like your parents or your teacher, you're always asking why about things. So dependent is y, independent is x. And when both of those increase, we have a positive association. Like we said, it's going uphill from left to right. And this is like what we saw in the warm-up. As the number of videos you watch increases, the time spent watching those videos also increases. So if we get 2 increases, we see those points going uphill from left to right. It's also like what we saw yesterday on the first page of our notes with the test scores. As the hours spent studying increases, your percentage earned on the test also increases. So that's positive association. The second scatter plot here shows us negative association, which, as we can see, of course, is going downhill from left to right. If we were to draw a line through those points, it would be going downhill, and it would have a negative slope. So a negative association shows us that as the independent variable increases, independent, independent variable increases, the dependent variable y, why is this so hard to spell? Dependent variable y decreases. Go ahead and highlight all those increase, decreases there. Like we said, we're going downhill with a negative association. So an example I could think of for a relationship that would have a negative association is, let's say my independent variable is the temperature outside, right? So from left to right, my temperature is increasing. And my dependent variable is ticket sales at an ice skating rink. Okay, what time of year would you typically go to an ice skating rink? Winter, right? When it's cold out. Now, obviously, you can go anytime because it's inside, but Typically, ice skating rinks get a lot more business when it's cold out. So if the temperature is really low, right down here, the ticket sales are going to be high. But as we get into the 70s, 80s, 90s, 100 degrees, you'll see those ticket sales for the ice skating rink going down. Does that make sense? Mm-hmm. That would be a negatively associated relationship. Right? So as the independent variable increases, as X gets bigger, Y gets smaller. Let me see if I can think of another one. I'll think of one. We'll come back to it. I want to just get through this so we can get started. Now, the third association, if we look at this scatter plot, is no association. What do we notice about the points on this graph? They're everywhere, right? We could even say that they're scattered. You can say they're scattered everywhere. We can't see a clear direction that these points are going. They're just all over the place. So this kind of scatter plot neither has a positive association nor a negative association. It's got no association whatsoever. So no association is when there's no noticeable relationship between the two variables presented. Go ahead and highlight no noticeable relationship. A scatter plot example that would have no association is something like, let's say my independent variable is your height, right? Your height. And your dependent variable is the number of pets that you have. Let's think logically. Would there be any relationship between your height and how many pets you have?
No.
No, right? How tall or short you are has absolutely nothing to do with how many pets you have. So that would be no association. Anyone think? Can anyone think of an example of a relationship that would have no association?
Cars.
Okay, cars. What do you mean by that?
Like driving and everything. What was the question?
So the question is, can you think of a relationship that would have no association, like height of a person and number of pets they have? That has no relationship whatsoever. Did you have one? And then I'll go to Ida. Yeah, exactly. That's a great example. How old someone is and how many cats they have. That has no relationship. Typically you think of people that have like 10, 20 cats as like older ladies. That might have some type of relationship. But for the most part, no, that doesn't. Ida, did you have one of them, Ross? How many times you brush your hair versus how many times you watch TV in a day. Perfect. No relationship there. Ross?
Halloween and Christmas. Or is that too?
Like how many people celebrate Halloween versus how many people celebrate Christmas? Good. Yeah, I would say that wouldn't have a very clear relationship. Yeah, I wouldn't say that has a relationship. They are both holidays, but if we get into specifics, like Christmas is technically a Christian holiday. Historically, Christians aren't super big fans of Halloween because it's like the devil. You know what I mean?
Yeah.
I'm not trying to get into religion or anything, but you might see actually a negative association there. The more people that celebrate Halloween, the less celebrate Christmas. I don't know. We could do a test and ask a bunch of people, which is what we're going to do with our project here in a little bit. Is that a dog?
No. Yeah.
Sounds like a dog barking.
That's not a dog.
I heard a dog.
I heard a dog.
Then it must be a chihuahua.
Anyway, those are great examples, and we'll explore more into this in a little bit. But I love it. I'm glad that you guys are thinking of things that are not related at all. We could go forever and ever with things that aren't related. It's a lot harder to come up with examples of two things that actually do have either a positive association or a negative association. Questions I could answer about any of those three options? Those are the only three options. Positive, negative, or none. All right? So that's going to be one of our IXLs, is looking at graphs just like this and determining whether it's positive, negative, or no association. Very, very easy, very straightforward. If they're scattered everywhere, that's none. If they're going uphill, that's positive. Downhill, that's negative. Let's take a look down at our last piece here. Can anyone volunteer to read this little section in the asterisk? Go ahead, Osase.
A cluster is a set of closely grouped data. Clusters are visible as highly concentrated areas of points on a scatter plot.
Absolutely. Thank you. So let's go ahead and highlight highly concentrated areas of points. What does it mean for something to be highly concentrated? People pay more attention to it. Good. If we're thinking of concentration, I love that. Yeah, Osase?
Has more than one thing in one part.
Say that one more time.
More than one thing in one part.
Exactly. That's great. More than one thing at one time. For example, if you go to Disneyland on a Saturday, that is a very highly concentrated area of people, right? But if you go to school on a Saturday, that's a very low concentration of people. So concentration means more things in one place or more occurrences at one time. So if we look at this plot here, we're comparing interval and duration. It doesn't matter really what we're talking about there. But I want you to take a moment, highlight two clusters of points, high concentrated areas of points that you see on this scatter plot. Go ahead and highlight them, circle them up, whatever you want. Take like 2 seconds.
Like a lot of people use.
Yeah, like for example, I see one cluster of points right there. Go ahead and circle or highlight a second cluster of points that you see. Thank you.
So that's basically just the ones that are like all together.
Exactly. That's what a cluster is. All right. Obviously, or hopefully, we should all see the same cluster right up here in the top right corner. So we could say that there's two clusters here. We could say there's a cluster around, what is this? This falls on like 50, 2. 50, 2. And then there's also a cluster that's around 80, 4. Now obviously all those points within that cluster are not exactly 50, 2 and 80, 4, but from the center of our cluster, that's kind of about where we end up with both of those. Do you see any outliers at all on this graph? Yeah, Roz, where's there an outlier?
Yeah, 40 and
40, 4. Exactly. Darius, you got a question?
Oh no.
Oh.
I'm gonna answer.
Which one? For the outlier? Okay, I appreciate it. Is that where you found an outlier too? Great. That's exactly right. So we're just trying to figure out how to recognize different things on a scatter plot. The main things are outliers, clusters, and association. Okay, outliers, clusters, and association. Questions I can answer about any of that? Perfect.